So good morning, everyone. So transitioning from a hardware geek to a couple of cloud geeks. So I'm Ron Abalera from Microsoft. First of all, let me thank Josh and the Hortonworks and now our Cloudera friends as well for having us here. So I'm Ron Abalera. I'm a cloud architect at Microsoft. Been with the Azure platform for almost 8 years now. Been doing nothing but Azure. My background is in distributed computing. I've been doing a lot of big data work. Been doing a lot of NoSQL work as well. Everything from Mongo to Cassandra, even HBase, a lot of even cloud native technologies like Cosmos DB lately. So work with a lot of developers. So work with customers primarily, but also work closely with our engineering team, which is why we're tag teaming it today. So I'd like to introduce Gaurav Kanade. Gaurav. So he's part of our engineering team with HDInsight, which we'll talk about here shortly. So we essentially are going to talk about the evolution of HBase in the cloud, some of the design patterns that we're seeing our customers when it comes to NoSQL technologies, what are some specific contributions Microsoft has made into the open source community and making HBase better, as well as just the overall journey, the journey from essentially an on-premise architecture to some of the cloud-born architectures. We'll show you some of the journeys our customers have gone through, some of the different changes, some of the things that you'll be surprised with. So we're happy to be here and tell you a little bit about the changes that we've seen over time. So hopefully everyone is familiar with Microsoft Azure. Just a quick show of hands, who's used the cloud? Oh, that's a good show of hands. Who's used the Microsoft Cloud? All right, that's a pretty good percentage still. So, for those who haven't used the Microsoft Cloud, Azure is the platform that we use. It allows developers, infrastructure folks to do a lot of interesting development, both from anything from virtual machines to compute, storage, networking, to more platform services. Like Hadoop as a service, like Kubernetes as a service, a bunch of other managed services, as well as some software as a service. But that's what Azure is. And HDInsight is that managed Hadoop as a service that we've been partnering with Hortonworks for a number of years, and now with Cloudera, to provide that easy experience for customers to be able to have a Hadoop cluster easy to provision, manage in the cloud. Right, so all the infrastructure burdens that customers are used to from an on-premise perspective was much easier, being able to deploy in minutes, being able to put different nodes in specific locations around the world, being able to replicate your data, choose your different sizes of nodes, being able to scale from different sizes of node capacities. A lot of that was made much easier for customers, let alone support, as well as not even having to deal with the licensing, discussion. But also HDInsight was also made from the ground up to cater to the open source community. We'll talk a little bit about some of the decisions from the early days of HDInsight, working with the engineering teams. Back then it was called Project Isotope internally at Microsoft. So there was a lot of interesting decisions that we had to make on behalf of customers as far as what HDInsight looked like. So one of the things about HDInsight is that obviously we wanted to keep the service up and running for our customers. So that's where the 99.9% uptime SLA. Of course, customers get to manage this. Even though we talk about it's a managed cluster, customers can still manage it through Embari. They have full SSH access, just like you would have if you had an HTTP cluster on premises or in a colo or wherever. But we also added some security features, such as an Apache Ranger as part of our enterprise security package, integration with Azure Active Directory, so easy ability to add single sign-on, multi-factor authentication, as well as role-based access control for HBase and your Hadoop packages. But HDInsight gave you the easy access to Kafka, to Spark, to Storm, HBase, basically any workload that you wanted to run from an HTTP perspective as a service is basically what HDInsight provided to you. So today we are at version 4.0. It is now in general availability. It is in full production as of last month, running Hadoop 3.0. So now it's obviously 3.0 was a major release. Most of the open source components have been upgraded, right? So a lot of improvements to Hive, Spark, as well as obviously the major version for HBase 2.0 and Phoenix 5, right? And now we've also upgraded the security package for HBase as well. So as far as some of the architectural patterns that we see with customers, I'll talk about two of them. So the first one is obviously working with developers. The most common use case that I see time and time again is just your standard operational store, right? Because of what HBase is, it's a low latency columnar data store, gives developers fast access to wide columnar data, especially when you have the replication capabilities. So for a lot of our web developers that just want to be able to create a web application and have easy access to that data, HDInsight allows you to put your data in multiple regions so you can have a globally distributed application on that data. So here is an example. I should probably use the clicker. So this is an example of one of our customers. Of course, it's anonymized per our customer's request. But this was a customer that wanted to essentially get off of their on-premises data center and move completely into cloud, right, to save money from data center costs, having to manage all that infrastructure. So moving from some legacy technologies, starting with infrastructure as a service, moving their HBase implementation. So initially, they were already invested in a NoSQL database, HBase in this instance. And HBase was great for what it did. But it was only kind of a one-trick pony, right? It was just a NoSQL store. It was also getting very expensive to maintain for them, because from a replication perspective, it's great if you were able just to replicate within a cluster, but if you're starting to replicate across geographic regions, having to maintain your MPLS networks, multiple data centers, it became very costly. And that's where HDInsight with HBase became a lot more friendly for them. And they started offloading much of that data from HBase to HDInsight, right? And then, now that data was in HDInsight, they could take advantage of that NoSQL operational store, as well as take advantage of some of the other goodness of Hadoop, which includes some of the machine learning, predictive analytics, doing some batch analytics as well in the background to give you some recommendation insights for customers in this particular case. So the second use case that we run into all the time is around IoT, right? It's the ingestion of events, ingestion of data from all sorts of different devices. Could be users, could be different things out there. Doing it at real-time processing. This is a very simplified architecture, obviously, getting events and processing it through Storm, right? Putting it into HBase, doing some batch analytics at any point in time, and then serving it to a web application. So a little bit more behind the scenes as far as a snippet of what we've helped customers with. This is one of the manufacturing customers that we helped with. So this instance, the IoT scenario became a lot more complex, multinational, globally distributed data, literally, with hundreds of thousands of different devices and now scaling into the millions. So think about millions of devices generating data multiple times per day, different sizes of messages. So the throughput requirements from a network perspective, from a writes perspective, those were enormous, and especially increasing the size of your NoSQL store as more devices came onto the network. So in this particular case, the events were being ingested with a PaaS service called Event Hubs, with Kafka support, with data being enriched with Storm. So it processed into, it was stored into HBase, being able to do some fast queries through Phoenix. Of course, applications out there still rely on a SQL server or a SQL implementation somewhere or another. So there was also a relational database as part of that, running some web jobs to do some summary data, and then of course having a web application to run dashboarding and mobile applications as well. So this is an example of where HBase was the foundation for the data to support all the telemetry ingestion from millions of devices. So it's really important for IoT scenarios for our customers. So as far as the HDInsight HBase journey, notice that we went back as far as June 2014, and HDInsight was already in 3.1. So HDInsight actually didn't join the HDInsight family until a little bit later down the journey. So there was an earlier version of HDInsight, but didn't have HBase. But during that time, we were running 0.98 back in June, and so that was with HDP 2.1. So we ran that same version for a couple of years until the HDP 2.4 came around, and then we were running 1.1. Of course, we worked closely hand in hand with Hortonworks, now Cloudera, to essentially test, certify, make sure these were hardened services, because of course we wanted to make sure that these were available for customers at that 99% SLA, and also tested with the security features in mind. Of course, HDP 3.0 was announced, so we put that in preview late last year in August, so we've been running that in preview for our customers, running the newest HBase 2.0, and then last month we went in full production, running in general availability. So Gaurav will talk a little bit about some of the new features about accelerated writes, as well as our premium block blobs here in a minute. But this is now the audience trivia phase. We actually do have some prizes to hand out. So we have some T-shirts. As well, I found out that we can actually give out an Azure subscription up to about $3,000, as far as I heard. So you can actually run Azure services, including HDInsight, for up to that much, and then it'll just freeze once you use that amount. But here's the trivia question. Going back, even predating this chart, in HDI 1.0, the choice of operating system, the distro of choice, was a very controversial decision within Microsoft. So if anyone can guess which operating system we decided to use at the early stages of HDInsight, will win that prize. So show of hands, or go to the microphone, who could guess? We have. Very good. That's right. So this open source project, right, which is primarily 100% Linux, the controversial decision within Microsoft was supported into Windows. So that hurt me right here, and believe me, as a customer advocate. The very first thing on my request for product engineering, even predating Warrior, was turn HDInsight into Linux. And thankfully, they listened to not our complaints, but our requests for updates. And that's when things turned around. So obviously, we understood why they did it. We wanted to support our .NET developers. There was a bunch of Windows Server shops out there that weren't familiar with Linux, right, or Hadoop for that matter. So that's part of the reasonings behind it. But at the end of the day, when it's a managed service and we were taking care of the operating system and all the infrastructure components behind it, it became less of a concern, and we wanted more of the shell and the operational capabilities to be more seamless with the rest of the industry. So that's where we made the decision to go dual path for a little bit of time, and then we went full bore with Linux running Ubuntu. So HDInsight was actually the very first Linux PaaS service on the Microsoft Cloud, and now we're at the point where Linux workloads are the fastest growing workloads in our cloud, and we're happy to say that. As an open source guy, that was my dream to make it that way, because it's not just a Windows world. Even at Microsoft, the name of the game has changed. But that was the controversial decision at the time, was just figuring out, hey, how do we support our open source customers? How do we have that innovation? And it didn't make sense to report everything and have a 6-month delay when we got the bits from Hortonworks. It made better sense to work hand in hand and just deliver these services as a native service in Azure. So the journey has changed. Obviously, the distro of choice, and the gentleman in the back, just see us at the booth, and we'll get you your prize whenever we see you. But just as a recap, as far as some of the how the things have been impacted with the cloud over the past few years. So capacity planning has been much more flexible. In the early days of talking with customers wanting to do Hadoop, it was all about nodes. It was all about servers, right? It was all about, hey, I need 5 nodes and 5 8-core machines or 5 16-core machines. So it was very interesting back then. No one really knew what kind of data problem they were solving. So it's nice now that we can actually talk about number of devices, number of messages, right? The sizes of messages. So it's not about just an infrastructure sizing discussion. It actually becomes more of a application, a workload discussion, as well as back then, people didn't even know how much they needed, right? Hey, I need 10 servers. Well, that's because your hardware rep may have told you need 10, but do you really need 10, right? Now, if you made the mistake on the capacity planning, you could change the size of your cluster with ease. So the capacity planning is much easier when it comes to sizing. The second thing, too, is the Azure networking made global replication and distribution much easier. Like I mentioned, in the early days, customers had to go through their networking team and security teams, setting up MPLS networks, setting up firewalls, just to have a second region. Those were painful just to be able to set those up. Now I can just create a virtual network and then create another virtual network, tie them together, using the Microsoft backbone, not touching the internet, and then being able to do that globally or wherever I needed to. Made it a lot easier to have your data close to the end application, to where the users were. But one of the challenges at the cloud was about this thing called separation of compute and storage. For those who've been working with Hadoop, one of the best things about Hadoop was the ability to leverage commodity hardware, right? And within a server, you had the ability to have the locality of CPU, memory, and storage. So immediately you had the liberty of having fast buses, and so moving the job to your data was really the name of the game when it came to Hadoop, right? But the problem with that architecture, as with every computer science challenge, that every benefit has a drawback, right? So the benefit was the ability just to move the job instead of your data, but the trade-off is now that your storage and your compute are tightly coupled. So data almost always grew, right, for most of our customers, but compute did not. There were times that our customers would have peak events, excuse me, like once a month. Sometimes it would be like a Super Bowl Sunday event, could be a Black Friday event. So there were times that compute went like this. And sometimes they were predictable, sometimes they were not predictable. But the fact that they essentially, the amount of storage growth and the compute growth were decoupled meant that we needed to change the game in terms of, hey, does a customer really need to pay for 1,000 cores when it's just a bunch of cold data that they're not really doing a bunch of queries with? So that's really where this whole thing about the old architecture about having direct LUNs on each box and spreading HDFS on those nodes. Essentially, we split them up into that object store, right? Being able to grow that object store, essentially it's a microservice. So your storage can grow and shrink whenever you need it, and then compute can grow and shrink as you need it, right? So you have that flexibility, you have that cost control, and you can get that capacity at the time that you need it. So that was the biggest controversial change, moving these particular workloads to the cloud, and HBase in particular, because in HBase, latency is one of the value props of a NoSQL store. So that's the reason why we're going to talk a little bit about how our engineering teams have worked on this particular challenge, because there are some ways to mitigate that issue, and Gaurav here will talk a little bit more about that. Gaurav.
Thanks, John. Thanks, everyone, for having me. So, yeah, so given that we now have our separated storage compute model that Ron just referred to, so we do have a look at, get a look at a lot of the advantages of this separated model, mainly to do with the elasticity that cloud storage provides. So like Ron mentioned, the capacity constraint is removed. You don't need to add nodes for your storage. You can only add nodes as per your throughput requirements. There was a HBase can't talk regarding this in the early days of HDI by some of my teammates, how this becomes economical. And also, for data durability and easy migration, a lot of our customers want to separate out their data, but move quickly to later versions, whether it's a hot fix, whether it's simply an upgrade in HDI service, and so on. This separated model helps with that. As far as consistency goes, Azure has multiple types of blob storage it provides. Key among them are block blob and page blob, especially for the HBase context. Block blob is a default large object store in Azure, optimized for quick streaming and store. But page blob is a different kind of blob which is optimized for random reads and writes, which is ideally suited for the write-ahead log scenario of HBase. So the combination of these two, along with the driver, the Windows Azure Storage Blob driver that Microsoft developed, makes HBase one of the first and few cloud offerings to have these strong consistency and durability guarantees required by HBase met. And like I mentioned, this driver is contributed by Microsoft back to the Hadoop project. Of course, like Ron mentioned, the challenges aspect of it mostly to do with latency and throughput. Now that we are going over the network, now that it's a remote storage. Also, there is certain storage throughput limits that Azure Storage provides on its accounts. What we found over the years that incorporating some of the already existing great features in HBase, such as batching to minimize these remote calls and bucket cache when it came in, we adapted it to suit our Azure VMs, as well as tuning our WASB driver appropriately to match the read-write block size going to and from Azure. We are able to cover a wide variety of customer scenarios pretty comfortably. However, there will be some high load, very latency sensitive, critical scenarios that still feel the pinch when it comes to these latency issues with remote storage. So recently, we came up with this new feature called accelerated writes. It's still in preview. What we do now is the rate files are still packed by remote storage on Azure blobs, but we put the write-ahead log on an HDFS mounted on a set of premium managed disks that are attached to your Azure VMs. So essentially, having two different file systems for the write-ahead log and data is already there in HBase, but we just use that combined with the latest technologies that Azure offered to have this feature. When we started, we hit some blocking issues, which probably were already out there, but just more of a cloud environment where they were exposed. We collaborated deeply with Cloudera to help accelerate fixes for this, and the results were really good when we saw them on YCSB. We saw like a 8x improvement in wall sync latency and 3x in the overall write throughput, which was what we were kind of looking for. So interestingly, while this started as an accelerated writes feature, it helped in an overall enhanced premium HBase performance, because now that your write-ahead log was no longer going to Azure Storage, we no longer had the page blob requirements which was primarily for the write-ahead log. We no longer had those. So for your data, we could use a different type of more premium block blob service, which has better throughput and latency guarantees from Azure. So now, even though we started as an enhanced write feature, we can use that combined with the premium block blobs, the latest Azure storage account type, to have an overall premium HBase performance. And the numbers tell how much of the improvement our customers have seen. So to conclude, before I hand back to Ron, I just sort of like to go over the kind of journey we faced as a service running HBase in the cloud, starting from the early days with some of the fundamental challenges we faced when we were still on Windows and the older generation of Azure VMs. We used to see stuff like ghost regions coming up and wall files growing and startup issues with the master service. And we went back and forth with a lot of Juras that Hortonworks filed on us at that time during certification. And we found that we had to basically tune and make robust our WASP driver, as well as help with some of the cloud-specific issues, Jiras that were out there, as well as just defining the optimal HDI cluster shape. Like in the early days, our gateway machine used to be a bottleneck. Our gateway machine is part of all HDI clusters, but for heavy workloads like HBase, it was not big enough, so we asked customers to deploy their app in the same VNet to bypass the gateway. To later on, as the Azure VMs improved and we moved to Linux, now our challenges are more geared towards perf issues. I already mentioned the wall latencies and the accelerated write solution we came up with. We also, when Phoenix Query Server came along, we found that initially it didn't have the batching API, which was crucial for our kind of remote storage model. So we worked closely with Hortonworks engineers, now Cloudera, to get that in and helped them with testing or benchmarking of the automation tools around that. And lately, as more and more enterprise customers come in, they are more concerned with higher level issues like security. So as Ron mentioned, the HDI ESP, the enterprise security package, Secure HBase is very much part of that. And I'd like to call out that here too, we came across several important issues that we reported and helped contribute back to the open source community. So with that, I'd like to hand it back to Ron to conclude.
All right, thanks, Gaurav. So as you noticed, this was HDInsight wasn't just about running HTTP and just making it available. It really was about engineering efforts with the community, with Hortonworks at the time, now Cloudera, to make sure that this was a service. So I wanted to put this slide just to show how far we've come. We do run into the occasional customer where they still think all we do is Windows and SQL. Like I said, the fastest growing workloads in Azure are open source. They're Linux. And it really started changing when we did get our CEO, right? And he really changed the culture internally and really allowed us technologists to essentially flourish and to really pursue our passions and contributing back. So everything that we've been doing as far as working with our partners and contributing back, whether it's Jira's, whether it's HBase, or contributing to the Azure Data Lake stuff, which is now fully supported with every Hadoop distro in 2.0 and higher. So these are all things that we've been doing as part of that journey in 2014. Notice that data is very much aligned with when we made that change from Windows to Linux. That's when the culture really started changing internally. So a lot of things really changed for us. So we contribute to a bunch of GitHub projects all the time. In fact, I run some NoSQL labs that are on GitHub. They're more around some of our Cosmos work, but you can see what we're contributing for our customers and with our partners. So we've come a long way over the past few years. So we just want to conclude. Just wanted to thank you. We wanted to just showcase how Microsoft's changed what we're doing when it comes to the evolution of HBase, and we're still working on that journey. We're never satisfied, but we have a lot of more in-depth stuff that we'd love to share with you. So we will have a booth in the expo. So Gaurav and I will be there. A couple other folks from our engineering team will be there as well. So if you want to get any more in-depth information, feel free to come to the booth and learn more. The gentleman in the back who won the prize will have some swag there as well. So we'll be happy to share those with you. But to learn more, there are some links to learn a little bit more about HDInsight as a service, the documentation, the blog. You could easily Google, and I'll even say that we could even Google some of the GitHub labs and projects around that as well. It's the new time of Microsoft. The cloud has really changed the game. So we want to thank you for your time. And so if you have any questions, we'll be here. Question?